right, so here is where we left off yesterday. We had completed a few examples of balancing chemical equations that were fairly similar to one another. And this is where we left off. So for your warm-up this morning, I've asked you to complete these final three on this side. And let's just talk about for a minute how we balance these equations. So we're going to go through them together to see if we got them right. So I have the equations there for me already. What is the first thing I should do in trying to balance this equation? Think about that for just a minute and raise your hand if you can tell me the first thing I need to do. Where do I start to balance this equation? What's the first thing I need to do, Joshua?
Determine the number of atoms for each element.
Very good, sir. I need to determine the number of atoms. I'm going to count my atoms on both sides of the equation first and foremost. So let's start there. Okay? How many nitrogen do I have on my reactant side of this equation? Very good. I have 2. How many hydrogen?
2.
Also 2. On my product side, I have a compound NH3. How many nitrogen?
1.
And how many hydrogen? Very good. Okay, first step accomplished. Now, are either of these balanced? No, they are not. I need to have the same number of nitrogen on my product side as I do on my reactant side, don't I? Yes. Okay, because I know I started with 2 in this reaction. I have to have the same amount on the product side. That matter did not disappear. Okay, same with hydrogen. So, where should we start? Where should we start? Davis says the product side. Any particular reason? There was something we wrote down in your notes yesterday, which, by the way, that would probably be a great thing to have out in front of you right now since we have those steps and we're not quite experts yet. Having your notes out as a resource is a really good idea. What do you think, Connor?
It's the most complicated.
The most complex compound. Thank you, sir. So, of these, which do you find to be the most complex compound?
NH3.
NH3. So let's see here. We'll start there. Now, we have 1 nitrogen and 3 hydrogen. Let's start and look at hydrogen here. We have 2 on this side, 3 on this side. Can we just add 1? No, because you know what? When we add coefficients, we're not using addition. We're using multiplication, right? So what's going to happen is you're going to have to find something that both 2 and 3 can go into, right? What is that called? Common denominator. We're looking for the lowest common denominator. So what is the lowest common denominator of 2 and 3? 6. Okay? So if we wanted to ensure that our hydrogen matched, what could we do? What did you do? I want you to share your thoughts with me, and it's okay if we mess up because that's how we learn. I don't want to just tell you. I want you to think about it and try. And if we stumble, that's okay. Davis.
I put a coefficient of 2 in the NH3.
Okay, you put a coefficient of 2 in front of where?
NH3.
NH3. And which side of our equation is that?
Product.
The product side. So why did you choose to put a coefficient of 2 right there?
Because it would make the hydrogen 6.
Okay. And we had just discussed how that is the lowest common denominator we're looking for. Okay? I cut you off there. Were you going to add anything else? Okay. Sorry. All right, so we've added a coefficient. Let's recount. How many nitrogen do I now have?
2.
Good. And how many hydrogen? All right.
So I managed to balance my nitrogen that way. However, my hydrogens still do not match. How can I now balance my equation so that my hydrogens are the same, have the same number of hydrogen atoms on both sides? Justin.
You have to put a coefficient of 3 on the reactant side in front of hydrogen.
Okay, he says to put a coefficient of 3 on the reactant side in front of hydrogen. How many of you did that? Okay, a couple of you. Let's see if that works. Okay, and remember the coefficient applies to everything after it. So let's recount. Our nitrogen are not affected by that coefficient. Our hydrogen, however, we now have how many? 3 times 2, we have 3 H2 molecules, is 6. Is that equation balanced? Yes, it is. Now, one thing that I noticed as I was walking around and taking a look at some of your papers, I noticed some of you were trying to get everything, all the nitrogen, all the hydrogen to the same number. You don't have to do that. That's not the idea. You're just trying to get the same, you're looking at individual elements. You want the elements to match on both sides. So the nitrogens need to be the same, but the nitrogens don't have to match the hydrogens. Does that make sense? Okay, you're just looking that your element over here matches your element on the product side. Okay, you don't have to have all of them match. All right, so let's try another one. Okay, where do we start? Where are we going to start? It's the first thing we need to do. Sam? A little bit louder, I couldn't hear you.
You list all the elements, how much each element has.
Okay, we're going to count up all our atoms or list how many atoms are in each formula. So let's do that. How many copper? How many oxygen on our reactant side? How many carbon? Okay. On our product side, how many copper? How many oxygen? And how many carbon? Okay, so we have all of, well, our carbon is balanced, but not our copper or our oxygen. Okay, would anybody like to suggest how I might proceed from here? Wes?
You start on the reactant side.
Okay, he says we're going to start with the most complex compound, which is on our reactant side. And in looking at that, he says we are going to need to add a coefficient of 2. Adding a coefficient of 2, what element will that help us balance over there? Okay, when we look at our oxygen, we know those are off. We know our copper's off too, so that is probably going to help us balance out our oxygen. Okay, so let's recount. We're having, going to cross these out. How many copper? How many oxygen? And remember, it doesn't affect our carbon because it's not going to jump over the plus sign. Coefficients don't jump over plus signs. Okay, so we did a pretty good job with just one fell swoop. Our carbon and our oxygen are balanced. Now we need to balance our copper. We have 4 here. We need 4 on our product side. This is a pretty simple fix. Lily, what do you think we should do? Fantastic. Where are we going to add that? In front of copper on our product side. And that only affects copper. It doesn't jump over the plus sign. So we can recount. Very good. Shall we try one more? Okay. Let's start by counting our atoms. You tell me. How many hydrogen? How many oxygen? Product side, hydrogen? And
Haha, that tricked some people I saw when I was walking around. You have 1 oxygen here. You have 2 oxygen here for a total of 3. They are all on the same side of the equation. Maybe I should turn this light on and we can see a little bit better. That's a little bit better. There we go. Okay. So,
Who would like to share now where you think we should start? We've counted? I know we're not confident yet, but we're going to get there. What do you think, CJ?
Want me to say everything? Or just
Let's just take it one step at a time. What's the first thing that you did?
I put a 3 in front of the H2O2
Okay. Why a 3?
because of like the other side. If I were to do that, it equals.
Okay. Thank you for sharing. Raise your hand if you put a 3 in front of the H2O2. Couple people. Do we have anybody that did anything differently? Okay. Patrick, what'd you do? And why did you put a 2 in front of the H2O2?
Because knowing that H2O and H2O2 will split hydrogens.
Okay, so you started with your most complex molecule and tried not to throw the hydrogens off balance. Okay? And I like the way that both of you started with the most complex compound. That's good. It helps you out in the long run.
so let's try that, Patrick. Okay. Okay, let's recount. How many hydrogen now?
4.
Very good. And how many oxygen? Because this coefficient applies to everything after. Okay. Now what?
I can see what's going to be the easiest one to fix first. What now? What do you think, Hunter?
I put a coefficient of 2 in front of H2O
You put a coefficient of 2 in front of H2O. Why did you do that?
because it'll get the hydrogen to 4 and the oxygen to 4.
Okay. It'll get the hydrogen to 4 and the oxygen to 4. Let's see if that's true. Our coefficient of 2 applies just to the H2O, so let's recount our hydrogen. How many? We have a total now of 4. 2 times 2. Now, we have oxygen 2 different places, which sometimes can trick you. Okay. So now, right here, how many oxygen do I have? 2. Oh, but I still have this one over here. So how many? I have a total now, 2 here and 2 there, for a total of 4.
Very nicely done. I am impressed with you. Yes, sir.
Do you want us to rewrite the equations?
You know what? You do not have to rewrite the equations, but sometimes I think it helps, especially if, just for you to see. But no, you are not required to do that.
He's asking if you need to rewrite the equations. You're always welcome to, just so you can see it better, but you are not required to. This would be H2O2 yields 2H2O plus O2. And I will ask, if ever you're not provided boxes, that you either underline your coefficients that you've added or box them in for me.
All right. You're doing a great job. So what I'd like for you to do is take a few minutes, and I would like you to try the 7 that are on the back. There's a challenge. So if you breeze through, if this is coming pretty easily and you breeze through the 7 on the back, you may try the challenge. Okay? So I'm going to give you a few minutes, just a little while. Remember, you start by counting your atoms. But since they didn't provide you with a space to do that, you will need to show your work, which just means show me your counting of atoms. And you know what I like to do sometimes? I draw a line through the arrow so that I separate my reactants and product side. So you could do Na and Mg and F. And then you want to make sure you keep the elements in order as you go across, that you don't write Na, F, Mg, because you're trying to see if they match across. So you want to keep them in order.
So just start there and count your atoms, and then try adding in coefficients. And then we'll talk about these in just a few minutes.
What is that?
All right, so you've had an opportunity to converse with your group. I've heard some disputes where you've come to a common ground on what needs to happen. There are two misconceptions that I've heard, and this happens every year. So let me clear up a few misconceptions. You must simplify. Okay? So in some cases where you're dealing with 4s and 8s, if you've got 4s and 8s as coefficients, what can we simplify those to? 2s and 4s. You want to have the lowest number possible. Okay? The other question that I heard, which is a fantastic question, is can you use decimals? What do you think the answer is and why? Okay, I'm hearing a lot of no's. Why do you think you cannot use decimals as coefficient, or numbers with decimals as coefficients? What do you think, Brennan?
You can't add half an atom or
You-
multiply it.
Very good. You don't have parts of atoms or half atoms. So that is why you must use whole numbers, because we're talking about whole atoms. We're not talking about halves or parts of atoms. So that is why we cannot use decimals. Now, I know you're chomping at the bit. So you and your group worked hard. There were some disputes that were resolved. So take a look here. Oops, we just need page 2, so let me zoom in. I want to show you the challenge yet. Okay, so take a look. And for instance, I saw several people here that had, like on number 2, for example, they had 2, 4, 2, 2. Simplified, that is 1, 2, and you don't have to write 1. You can if you want to, but don't have to. 1, 2, 1, 1. So you want to make sure your answers are simplified. Raise your hand if you and your table, having discussed these balanced equations, got at least 5 right. All right. How about 6 right? Awesome. How about 7 right? Very good. You are catching on. Very good. Now, do you want to see the challenge?
Yes.
I've seen some right answers.
I think I did it.
I've seen some right answers and I've seen some wrong answers. All right. Here it is. I'm sorry that I don't have the counted atoms there. If you do not have this, you probably want to go back and check your math. Part of what throws people on this one are having oxygen 2 places on the product side. That's what's throwing a lot of people. Okay. Now, I have a little activity for you that is going to continue with our practice of balancing equations, and you are going to be using some manipulatives. Okay? I have color-coded pieces of equations that you are going to be constructing, and with your group, using those and rearranging those to balance the equation. The equation. So if you'll please clear your desk for me. Now let me see which one you are building. You are building the first one, right? Yeah. H2O2 and H2O. So label your reactant side and your product side. There we go. Good job. Now you've got a stack of cards. Let's find coefficients and balance this equation.
What's plus signs? That arrow.
Wait, you would. Am I doing this for?
You want to start by building the equation. Start by building the equation.
H2 plus
H2
O2.
plus O2 H2O. Don't get ready.
Okay.
Okay.
Now what do you need to do?
Count the reactants.
Okay, you've got coefficients in your stack.
Reactants.
That's right, label your size.
Products.
Oh, I got it.
Now, ladies and gentlemen, quick timeout. Quick timeout. All right, one thing that you may want to do, you are welcome to have out a sheet of paper where you can count atoms and tally them up. Okay? You don't have to, but you may want to. Okay? That was all.
Okay, now count them. So, 4 reactants.
Are there?
Yeah, because look.
Was this starting or? Oh no.
Yeah, this is just right there. Reactants.
So put 4, and then products is
3.
reactants.
Reactants final, does that mean?
So now we have to do 2, 2, 2, 2. So put a 2 here, and 2 here, and 2 there.
Okay. We'll place them there and then see if you like it. See if that works.
2.
Where are we putting the 2? Right here? Right here?
We need another 2.
Okay. So now on your reactant side, how many?
Oh, here we go.
Okay, you're not putting it.
Yeah, that'd be H4.
So
H4.
So-
O4. H4.
That would be 4.
H2.
So there's CJ throwing elements everywhere.
Okay.
H4.
Yeah.
so 4, 2, 4.
All right. Good job.
Okay, reactants final then.
6. And this is 6.
Wait, wouldn't it be?
It'd be
6.
4. It'd be 6.
Yeah, 6. 6.
We just write yes on that.
It's balanced, yeah, because 6.
You're going to write the final balanced equation.
Oh, okay.
Okay, you have to multiply everything. Everything you divide that by 2.
Wait, is it balanced? So that would be 4.
Multiply.
We got 4H, 4O.
Yeah,
Multiply. Yeah, that like 2.
That's 4.
Hold on. Okay. There you go. I didn't think you noticed your last oxygen.
Now we have
Okay. Good.
NA plus O2.
Wait, write down the product first.
Okay, now what's next? The N right there. Right.
Katie, write down the product first.
Okay. We need to write this out. Okay. Okay, so now we're going to have to make those equal. So there's so that there's one of those, 2. Then 2 of those and 1 of those. So we have to make those equal. So we can add a 2 right here. Right. So cross it out and that would be 2. And then we need this, add 2, and that would change sodium to 4. Right. So then we'd actually make that one a 4. And then we still have 2, so that would be right. So 4 plus 4, 2 is 2. Okay, so 4 and